So this brings us to the segment of our session where we said we will show you the work that has been done by students of biomimicry. Now, what you will see is students have taken the biomimicry process and applied it to a problem or the other. Now, as you go through this process, there are a couple of things that I urge you to remember. One is that this is not about the idea that you see on the screen. It's not about the idea. We are not trying to say that this is a great idea and therefore you should also generate ideas like this. That is not the intent of this case study at all. What we are trying to share with you here is the way in which a person, a student just like you of biomimicry, of nature, has applied the process in order to solve a problem that they have defined. And so please pay attention in the case study to the process that they have followed rather than the specific idea or the specific organism or the specific question that they have used as part of their work. This will also help you understand that, so these students were also new to biomimicry when they started, right? So they have then put their faith in the process, and that's an important thing to do. You should trust the process as you work to solve problems using biomimicry. Because many a time what happens is we get disappointed with our own ideas and say, oh, this is not working. I got this idea, but it's not as good as XYZ idea. So therefore, maybe I'm not doing it properly. But I will urge you to not think like that. The important thing here is to trust the process, go with the process, and remember this is not a linear process. You are not going to be able to just go through the steps, linearly 1, 2, 3, 4 and boom, you get a great idea, etc. and you are going to file for a patent. That's not going to happen. It's an iterative process. Many times, even in the first step, once you get to the second step, you will find yourself going back to the first step and trying to redo something that you've done. And that's perfectly fine. And you will get, like anything else in life and in professions, as you apply it, as you work with it, you will get better and better at it. And that's what I will urge you to remember as you look at these student case studies. So what I'm going to do is I'm going to share a student case study. Unfortunately, the student is not here to present it to you. So I am presenting the case study on behalf of this student of biomimicry. Now, this is Nandagopal. He's not here today. He's from the Department of Metallurgical and Materials Engineering at IIT Madras. And what he has done is he has used this framework, the UN Sustainable Development Goals framework, in order to select a problem. Remember that we spoke about this, right? The difficult part in creativity is to find out the problem that you want to solve. That's a difficult part in creativity. And here you have a framework with a ready-made set of problems. The 17 Sustainable Development Goals, these are all very important problems, big problems that we need to solve as part of, the world needs answers to this, right? So therefore, Nandagopal has picked up goal number 7, which is affordable and clean energy. I'm not going to go through each of these goals because that's something that we will do eventually in one of the other sessions. So Nandagopal has taken goal number 7, which is affordable and clean energy. Now, why did he choose this? Because he had a deep emotional connect to this goal, because he felt very strongly about energy efficiency and the wastage of energy and the costs that were being racked up because of wastage of energy. And that's the reason he chose this particular goal. And it's not enough if you just select the goal, right? You can't just say affordable and clean energy and I'm going to solve the problem of affordable clean energy. It doesn't work like that. It just cannot work like that. You can't solve the problem of affordable and clean energy just like that. So therefore, each of these goals also have targets which are specific outcomes that need to be achieved and indicators which show that how would you know that this outcome has been achieved. So there are specific targets and indicators that Nandagopal has selected. In this case, it is 7.2 and 7.3. I'm not really reading it, but suffice to say that it's about increasing the share of renewable energy in the global energy mix. And to make sure that energy intensity, the energy efficiencies are improved, doubled rather, across the world. So this is the target that he's chosen to work with. Given that he's chosen to work with this target, the important thing that Nandagopal also has to do is to look at information pertaining to these targets. It's not enough that you look at this target and say, oh great, this target looks very beautiful. Let me start spending my energy on this and I'm going to look for an idea. No. It's important for you to look for information. It's important for you to look at the targets and understand what this actually means. What does the problem of energy efficiency actually mean? What does the problem of increasing the share of renewable energy actually mean? What is it currently? What do you want it to be? How do you think that can happen? What is being done today currently? Why is it a problem? These are all questions that will get answered only if you start looking for information on the targets that you select, and that's exactly what the student has done. Now, this is the process that he's applied. We will look at it in detail, this process. It's, as I mentioned before, it's an iterative process. You start with defining the problem. You then do what is called biologizing. We'll see what that means. Then you discover the organisms, you abstract your strategies and emulate those strategies and evaluate the solution that you came up with. And you could go back and forth in this process several times before you come to a solution. And even after you come to a solution, you might decide that there's something that you need to refine based on some new information or something else that you feel has to be refined. So that's the biomimicry process for you. So let's see how in this case the student has applied this. Starting with define. Remember, he's selected affordable and clean energy. And in affordable and clean energy, he selected 2 targets. Now, what are those 2 targets? Based on that, he has defined a problem here. And this is a critical part of the process, is to define what is it that you want to solve. It sounds like a trivial problem, but it's not. Because many times people are disappointed by their ideas because they are solving the wrong problem. Many times people are disappointed by their ideas because they don't solve the problem for the stakeholders that they intended to solve for. And that's why understanding the problem is a critical part. Defining the problem, scoping the problem out is a very critical part of this. So what the student Nandagopal has done here is how might we manage heat loss from energy storage and energy utilizing devices to improve energy efficiency. So after all his research into this problem of energy efficiency, this is what he has defined. Now, why does he think it is important? He feels this is important because of the reasons, the emotional connect he has, of course. Also, he has figured out that various industrial processes, the energy loss via heat exchange is a critical problem for them and it's adding to their cost of operations, which is why he has chosen this problem. So having said that, saying, okay, this is the problem that I wish to define, he then moves on to the next step, which you can see is biologize. Now, biologize, what does biologize mean? Because it's a new word, right? What does the meaning of biologize? Biologize is how does nature accomplish what I want to do? In define, what have you done? You have defined the problem that you wish to address. And in biologize, you're asking the question, how does nature accomplish the same thing? Because this is biomimicry, right? We have to look at nature to do something. So this is what it is. How does nature accomplish what I wish to address? And when you do that, you start looking at functions in nature. Function is the way something is the purpose of something or the outcome of something. So what is the functions in nature that are related to the problem you wish to solve? So the student's problem is energy efficiency, remember, increasing energy efficiency, improving energy efficiency. So he has looked at related functions in nature as storing energy, distributing energy, transforming or converting energy, conserving energy, and also maintaining temperatures. So there is a wealth of functions that he can look at as part of this. And then ask the important question, how does nature do something? So this is it. That's the critical part in biologize. How does nature store the energy that it captures? How does nature conserve energy in humid climates? How does nature keep warm in cool areas? How does nature keep cool in hot weather? How does nature distribute energy with minimum loss? So in each of these cases, remember your problem is there, But you're not going to ask how does nature do energy efficiency. That's not the way it works. You're looking at functions that are related to this specific problem and looking at, therefore, how does nature accomplish that function. So, having done biologize, which is the next step of the biomimicry spiral, what you need to do next, it would be discover. So, in discover, what are you doing? You're looking at organisms that perform the same function as you mentioned in your biologize step. So, you spoke about, remember in the biologize step, you're looking at storing energy, conserving energy, keeping warm in cold areas, remaining cool in hot areas. All of these are related to energy efficiency. So, therefore, the next step would be to look at organisms that are performing these functions, because these organisms will kind of serve as our role models. So, looking at the organisms, here the student has looked at the polar bear. Now, it's not enough to look at the polar bear and say, oh, the polar bear keeps warm in cold climates. That's not enough. You have to actually look at the organism and look at what is the strategy that the organism is employing. In this case, it's the guard fur that the polar bear is using in order to keep warm. And there is a specific strategy. I'm not going to go through every strategy here, but I just want to call your attention to that. So, polar bears live in very cold conditions. However, they are warm-blooded animals, right? So, they maintain that temperature with the help of this thick fur coat. And how do they do that? With the help of the guard fur that has certain special properties that absorbs the infrared radiation and therefore keeps the animal warm. Now, this is an important biological strategy that that Nandagopal, the student, thought can be applied in this case, the function that they are looking to perform. The next one is the numbat. The numbat is an animal which also keeps warm, and it keeps warm in a very counterintuitive manner. There's a counterintuitive technique that it uses to keep itself warm. It has a very thin fur, but it is still able to stay warm because of trapping the air around its skin using a special strategy. And that's the numbat for you. So, this is another organism that is doing the same thing that I want to do as a function, which is to keep warm in a cold climate. Now, this is an interesting organism, the malleefowl. The malleefowl is a bird which does not sit on the eggs in order to incubate them. Now, that's very interesting, right? And why is this related? The function that you're looking at is keeping warm, conserving energy, etc. So, the malleefowl is using a specific technique in order to conserve energy and in order to incubate its eggs. So, what is it? It's using a combination of rotting vegetation which produces heat, and it covers these eggs with sand. So, and it also makes sure that it doesn't get too hot so that the eggs get cooked. So, this is a very interesting, again, I'm not going through each strategy in detail. I'm just trying to pique your curiosity on the strategy so that you can see that there is a diverse set of strategies that the student has looked at in order to look at the concept of energy efficiency and conserving energy. So, that's the other organism that they've looked at. So, these are three organisms that are doing something that is related to what I want to do. Wonderful. What do you do next? You move on to the next step, which is abstract. Now, abstract is probably the most critical step when you come to applying this biomimicry spiral. The reason for that being that it's great that you've looked at an organism and what it does, but here what you do is you abstract the strategy. What is the meaning of abstracting a strategy? You remove the biological parts and you look at the key principle of how it actually does it. So, you're moving from a specific biological strategy and generalizing it to a strategy that can be applied in any context, and that is what abstracting a strategy means. So, you move from a biological strategy to a design strategy. So, when you do abstract the strategy, the organism is not important. What you're doing is what actually is the organism doing is what you're trying to understand by doing this abstraction. And the good way to do an abstraction is, of course, to draw a figure that explains how it is being done. So, remember the polar bear that Nandagopal has looked at. So, he has abstracted the strategy here in terms of how the polar bear does it with the guard hairs on the fur. and then abstracted it out to say that there are different layers here which actually aid in the insulation of the animal's body and keep it at a certain temperature. If you notice the abstraction of design strategies, student has not mentioned the name of the organism at all. So when you look at the strategy, it's not important whether this is from a polar bear or from the numbat or from the malleefowl or whichever other organism you've looked at. And that is what abstract is about. Abstract is about moving from the specific to the general. You're actually taking out the design strategy, removing the biological terms so as to be able to apply it in any context whatsoever. So here is a strategy that has been abstracted in terms of insulation. Of course, I can tell you here that this is the strategy abstracted from the numbats, what the numbat does. And here is a diagram that explains how that works. Likewise, for the malleefowl as well. So how does malleefowl make sure that the eggs stay at a certain temperature and incubated? Now, it's not important to mention eggs or the sand or anything else, but it's about how does it keep them incubated. So that's the strategy here. And based on all of this, come to the next step, which is the emulate step. The emulate step is, I have a set of design strategies now. Remember, these design strategies are not about a specific organism. I'm not interested in the organism right now. All I'm interested in is, I've got a bunch of strategies of functions that are being performed in a certain way. How do I apply it in order to solve the problem that I defined in the first step? So if you recall, the problem that was defined in the first step was, I'm just going back there, is how can we manage heat loss from energy storage and energy utilizing devices? So given this is my question, this is what the student set out to solve, and given that he has looked at multiple organisms that do similar functions, the idea that he's come up with is this: a surface to improve insulation capacity based on the design strategies that he has extracted from the three organisms, the polar bear, the numbat and the malleefowl. So this, again, as I said, the idea is not important. You may look at the idea and say, oh, what is this? This is just a blah blah idea. But that's not important. The important thing is that the process is what led to the idea. Now, you may try other ways to get ideas, but in this case, you apply the process and you get an idea that actually you may not have got in other ways. The way that Nandagopal has gone about getting into a surface that improves insulation capacity is by learning lessons from nature, is by learning lessons from specific organisms in nature. And that's why he has come up with this idea to improve the surface. So that's the emulate step for you. Now that's not the end, of course. It's not enough if you just say, oh great, I have this idea, what do I do with it? I have created a great idea. That's not the end of it. So the spiral also urges you to evaluate your idea. Now evaluate is an important step, especially if you're looking to implement your idea, you're looking to deploy the idea. So it involves looking at who the stakeholders are, what could be the problems with your idea, what are the good things about the idea, can you look at the problems and fix those problems, can you look at the good things, can you enhance those things, find out what the stakeholders actually want, find out what materials you need to use. Remember that you're doing biomimicry, so therefore you will also have to apply the design principles of nature, what we talked about, the unifying patterns. How will I go about applying those unifying patterns in this solution that I have come up with? So that's an important part of the evaluate process. So that's what the student has done here, looking at how can I follow the nature's design principles in my solution design, and also what would be the immediate next steps in order to deploy my solution. So this is, of course, this is not the end of the whole thing. You could go back and say, okay, I figured out that this is probably not the best way to do something and actually redo something as part. You could go back to the abstract stage and say, okay, I didn't look at this aspect of the design. Let me now bring that into my design. You could go back to the biologize stage and say, okay, this is a function that I need to probably look at and bring in that function as well. So it's an extremely iterative process. It's not just a linear process that you just go through, as I mentioned. And at the end of it, the idea is to come up with a solution that can actually work in the real world, because that is the purpose of biomimicry, right? Learning a lesson from nature and using it, rather learning a lesson from nature, extracting those principles, extracting those design principles and strategies and using it to solve a problem in the real world, in the human world rather. So that's the process for you. So that's Nandagopal's idea for you. Thanks, Nandagopal, for letting us present on your behalf. Of course, it would have been great if you'd been here to present it yourself, because nothing like hearing it from the person who actually applied the process. But I hope we've done justice to it. And for all of you who are watching this, hope this will inspire you to actually do it on your own as well.